Hello children, how are you? Today children we will be talking about three-dimensional figures. The first figure that I am going to discuss with you is a cuboid. Now what is a cuboid? Just I have taken an example in my hand to make it clear to you. Now this is a box beta which has got 1, 2, 3, 4, 5 and 6 faces. Clear? Now as you can see, the front face of this is a rectangle. This is the length of the rectangle, this is the breadth of the rectangle. And this opposite face to it is the same. Similarly, this face is also a rectangle and there is a congruent face on this side also of the same. Similarly, the top of this box is also a rectangle and the face facing downwards is also a rectangle. So what do you see children? In a rectangle, clear, in a cuboid, we have got 6 different faces out of which each 2 faces are alike. Clear? Now there are 3 things which make up a cuboid. The length, okay, the breadth of the rectangle and this is the height. Clear? So when any rectangular face is given a height, clear, it becomes a cuboid. Clear beta? Now as I told you, there are 6 faces in this cuboid. Then we will find the area of all the 6 faces to find the total surface area of the cuboid. Now first of all, we will derive the total surface area of a cuboid. Children, when we have to talk about the total surface area, now if you see this side, this is the length and this is the height as I told you. That means length into height is the area of this face and there is a face identical to this face on the opposite side. So that means I have another length into height on the opposite face. Clear children? Similarly, this is the breadth and this is the height. So therefore, this face has got the area breadth into height and identical to this on the opposite side children. Again I have another breadth into height. Now I come to the bottom face. The bottom face is like this. This is the length and this is the breadth. So therefore, the bottom face has got the area length into breadth and identical to it, the top face also has the area length into breadth. So what do you see beta? What I see is I have got 2 length into height, I have got 2 breadth into height and I have got 2 length into breadth. So what is common in them? 2 is common in them. So what I get is L into H plus B into H plus L into B, or I can also write it 2 length into breadth, breadth into height plus length into height. So this is children the total surface area of a cuboid. TSA is the short form of writing total surface area of cuboid. Now children, if I talk about an open box or I talk about a box which does not have a top and a bottom, clear, then the only dimensions that I will have will be, these will be called the 4 walls, 1, 2, 3 and 4. So when I talk about the 4 walls, I will not have the base and I will not have the top. So therefore, that will become the lateral surface area. So lateral surface area, or I can say the area of 4 walls. The area of 4 walls will be given by the formula 2. I will not have this and this. I will not have, because the top and the bottom faces have 2 dimensions length into breadth. So I will not have the length into breadth beta here. I will have 2 LB and LH and BH. Clear? Now out of this H can be taken out common. So when I take out H common, I will have a formula of the lateral surface area or the area of 4 walls, which will be equal to 2 length plus breadth into height. Is it clear? Now children, we will be discussing about a cube. Now what is the difference between a cube and a cuboid? In a cuboid you found that the length, breadth and height all were different. But when you talk about a cube, all the length, the breadth and the height, they will be equal and they will be called the side of the cube. Now when I will be talking about the total surface area of the cube, beta. Now as I told you, in the cuboid there are 6 different faces. So similarly, if I talk about each of the face of this cube, you can well see that the shape of the face is square. That means we have got 6 squares in this cube. So therefore, the total surface area of the cube will be equal to 6 multiplied by the area of a square. And we have already done in 2-dimensional figures that the area of the square is equal to side square. So therefore, the total surface area of cube will be equal to 6 side square. Next beta, we will be talking about the lateral surface area of a cube, or as I told you, area of 4 walls. Now children, when we will be talking about 4 walls, we will not have the top and the bottom. Clear? That means we will have only how many squares now? 4 squares, and therefore the lateral surface area of a cube becomes equal to 4 into side square. Hope you are clear with this. Now children, we will be talking about a cylinder. Now how first of all a cylinder is made, I will be explaining you. See, I have taken a sheet of paper which is in the shape of a rectangle. Now when I roll this sheet of paper, right, okay, and I join this edge with this edge, then this shape that I am getting is a cylinder. Clear beta? I can roll it along this side also. Clear? If I roll it along this side, children, so you can see that, very well see that this rolling along this side also, we will get a cylinder. Okay? So this chalk that I am holding in my hand also, that is also in the shape of a cylinder. Right? So when I talk about a cylinder, see, I will show you, this is a mark that I am having in my hand. This is also in the shape of a cylinder. Now children, when I will be having a cylinder, now this is called the curved surface area of the cylinder. Clear? So I will show you that there was a rectangular sheet of paper. Clear? This was a rectangular sheet of paper. This was the length and this was the breadth of that sheet, and I rolled that to make a cylinder. Now children, when I rolled it, okay? Now see, when I rolled it, it took up the shape of a cylinder. Now see, this length became the circumference of the base. Clear? And we have already discussed that the circumference of the base is equal to 2 pi r. Circumference of the base of the cylinder is 2 pi r. And this breadth became the height of the cylinder. So breadth is equal to height of the cylinder, and the base, which was the length, is the circumference of the circle. So when we have to find the area of this sheet, now you know the length multiplied by breadth is equal to the area of the sheet. So therefore length is 2 pi r and the breadth is equal to h. So when I multiply them, I get the lateral surface area of a cylinder is equal to beta 2 pi r h. The curved part, the lateral surface area, or we can also say the curved surface area of the cylinder is equal to 2 pi r h. Clear beta? Now if I have to find the total surface area. Now just see, the top and the bottom faces are circles. The area of the circle, as we have already discussed in the second exercise, the area of the circle is pi r square. So we have got 2 circles with area pi r square. So therefore, the total surface area of the cylinder, beta, that will be equal to 2 pi rh, which is my curved surface area, plus pi r square and pi r square 2 times becomes 2 pi r square. Now let us take out what is common in them. From this and this, you can take out 2 pi r common and you are left with h plus r. So children, this is a formula for the total surface area of a cylinder, which is 2 pi r bracket start h plus r. Now if my cylinder is open, say for example, I have a glass of water. Now when I have a glass of water, this part is closed whereas this part is open. That means if I have an open cylinder, children, then the area of the cylinder will be 2 pi r, which is the curved part. Adding to it only one circle, that is only pi r square we add to it. So this becomes the area of an open cylinder. Hope it's clear to you.